Here we're going to be looking at the chi-square contingency table. So this is a particular type of distribution that we can use when we're looking at testing independence of variables. And we're going to look at an example of where this is very useful. So with the chi-square contingency table, you've basically got a summary table of your outcomes. This is a two-way frequency table at its very and it has at its minimum 2 rows and 2 columns. So here we can see an example set up where we would have a number of rows here, group 1 all the way down through any really infinite number of groups. And then along the top, we see the columns, that those are the outcomes. And again, you could really have those for an infinite number of outcomes. However, at its very basic part, a chi-square contingency table is going to have at least 2 rows, ergo 2 groups, and at least 2 columns, ergo 2 outcomes that you're going to be looking at. Now, the test of independence, here's what we're looking at, is the null that the row and the column variables are independent of each other. So this is the starting assumption we have, that there is no relationship between the group and the outcome, okay? So our rows and our columns are not related to each other in any way. So this would mean that the type of outcome is not dependent on group membership. So when we're doing the chi-square contingency table, again, this is a test of independence. That is our assuming null, that the rows and the column variables are independent to each other and thus not related to each other in any way. If we find that we reject the null, that would mean that in fact there is a relationship between the rows and the columns, ergo your group membership is in some way related to the type of outcome you have. So let's take a look at this with a practice problem. So we're going to do problem number 8 on page 557. This is a classic example of where we would use chi-squares in order to be looking at possible meaningful differences. So this is from a U.S. Supreme Court case where they were considering a case involving the exam for a firefighter lieutenant. And it was claimed that the test itself led to discrimination in that white candidates were more likely to pass the exam than minority candidates. And this would be an example of what we call systematic discrimination. Now, this is really important to talk about and be able to examine because many assessments were put in place during times that were historically either had norms of sexism, racism, or whatever other ageism kind of ism we might have, ageism, any of them. So if an exam or other procedure is put in place during a time period where discrimination of a particular group is pretty much taken as the social norm, it's possible that those components will in fact have built into them subtle but influential discrimination. So it's really important to be able to understand this, especially as y'all are going out into the world and often find yourself in leadership positions. It'll be important for you to understand the difference between systematic discrimination and individual discrimination. So a systematic discrimination, such as a test that unintentionally at this point makes it more likely for white candidates to pass, is systematic discrimination. It doesn't require anybody at this point in time to want to have more white candidates passing. However, the effect is still the same. So when we're looking at this, again, it's important to understand that instances of discrimination or prejudice don't necessarily have to have a person who is willingly targeting another individual. They can be built into the system. However, the person experiencing the discrimination, it's still just as powerful. So whether or not I'm on the receiving end of discrimination and whether the person means to be discriminated against me, or we're using an assessment style that, for example, underpredicts success for women and thus I'm excluded from an opportunity, in both cases I'm at a disadvantage. So systematic discrimination is very important to be mindful of and to realize that as a result of particular historical time periods when particular assessments were put in place. And part of being able to produce a society that is free of prejudice and discrimination is being able to identify and correct these instances when we find them. So here we are looking at a case that is examining systematic discrimination here. And so they're putting forward the claim that the results from the test should be thrown out. They should not be used for making assessments for promotion to firefighter lieutenant because they are discriminatory. And we can see here the data they're working with. So if we're looking at this data, we can see that definitely fewer minority candidates passed than white candidates, and they have a high rate of failing compared to white candidates. However, when we're looking at this, this alone, of course, is a good evidence to ask a question, but it is not sufficient evidence to make a charge. Why would this not be sufficient evidence to make a charge? Well, because we don't know what the variation is. So we don't know what the systematic variation or the standard deviation for this test is. Could these fall within the normal range of standard deviation? And also a single set of tests like this, there's always random chance. So remember, that's what we always look at, is just random chance. And we use statistics to be able to assess the likelihood of this difference in scores not being within the standard variation for the assessment or for just random chance. So certainly when we're looking at raw numbers, they're a good reason to ask questions, but we need analysis to come to a final conclusion. So that's what we're going to be looking at here, and we're going to be using a significance level of 0.01. So what's going to be our first step here before we move forward? What do we always have to do before we start our analyses? We're going to have to check our requirements. So what are the 3 requirements that we have for doing chi-square? Well, we need to have a simple random sample. We need to have sample data that consists of frequency counts for each of the different categories. And for each category, we need to have an expected frequency that is at least 5. So here we can see we have our sample data. We have frequency counts for each of the different 4 categories. Now, to be able to assess this last step in our expected frequencies, we need to go take a look at calculating expected frequencies for a contingency table. So when you're doing a contingency table, you have to calculate an expected frequency for each cell. And this is the formula we use. We take the total frequency for the associated row, times it by the total frequency for the associated column, and then we divide that by the total of all frequencies in the table. So let's take a look at, if we're looking at the expected for the white candidate passes, we're going to see here that our total frequency for the associated row is 33. Our total frequency for the associated column is 26. And you see I've added up a total number of frequencies here. We have 67 people in the set. So my expected value for white candidates passing is going to be 33 times 26 divided by 67. So what is that going to give me? That's going to give me 12.8. So that is my expected value for the cell of white candidates who pass. Now we need to go through this for all the rest of them. So pause the video here, go through and figure out the expected value for each of the remaining 3 cells. And once you've got that completed, turn the video back on and we'll proceed from there together. Okay, so here are the expected values we should have for each of our cells: 12.8, 20.19, 13.19, and 20.80. So again, we can see that there are differences between our expected cell values and our observed. But again, we're going to need to do an analysis to assess and see whether or not that is sufficient within the standard variation for the test, and also in terms of random chance. So, however, we can see that we do have for each category the expected frequency is at least 5, so we've met all of our requirements here for doing the chi-square contingency table. So our next step is going to be what? Well, we're going to be able to look at the claims and hypotheses that we're testing and put them in symbolic form. So again, I like to start down here figuring out my alternative hypothesis first, right? Because that's pulling from the claim that you're given in your description. So here in my alternative, we're stating that the results from the test should be thrown out because they are discriminatory. So if we're writing that out in proper language for the alternative hypotheses, that is going to look like this. So we would say the outcome of the test is dependent of or related to the candidate's race, right? Because that's what that would mean. If they're discriminatory, then that means my probability of passing the test is partially determined by my race, and that would thus make it a discriminatory test. Now the next step is we have to go back and figure out our null. So what's the outcome would be if the opposite of H1, and as we looked at just previously, if the test, the goal of the test is testing here for independence. That is going to be that the outcome of the test is independent of or not related to the candidate's race. So here are my 2 different statements that I'm looking at. And now just to be clear, let's make sure that we can connect this language explicitly with the measurements in the table. And for that, we're going to see that if we are testing independent, that means the row and the column variables are not related to each other in any way, right? And that's what we're going to be assessing with our analyses. And if they is dependent, the row and column variables are related to each other. So if we're looking at this, now we've got presented in terms of our hypotheses, and we're going to stop here with this video. You need to move on to the next video where we're going to look at doing the analyses.